for this specific class, if you don't guys attend, you will have difficulty doing the lab. So do not rely on the instructions by themselves. You really have to attend the class. If you cannot make it, you still will have a recording. I know this class ends late, and most likely the recording will not be available until Friday morning. So you still have a chance. You can go and watch the recording because you need to know how to do your lab. Each lab has specific instructions. It's going to be different. It's going to be looking slightly different, use probably different resources. So you really need, it has different rubrics too. You need to really either come live, that's what the preferred way of doing business, so that if you have a question, it makes the topic a little bit more interesting. Now, if you cannot make it, you have to go into the discussion. They basically the discussion link that will be provided immediately after, and watch the lab. So there will be actually down the road basically prompts to try to answer them to make this thing interacting. Okay. Again, for those who are taking Physics 10, they know exactly how this one works, or at least they have an idea of how this one works, because we've been at it for at least 2 other sessions before this one. But for you guys, this is new to you. So for the others, I should say, it's new to you. So the way it works, again, is that you have to attend the live sessions, and they're on Canvas. When you go on Canvas, it's under Confer Zoom. You're going to see the link there. You come into the session during the time when it's supposed to meet, which is 6 p.m. on Thursday. And then if you cannot make it, let's say, for example, you're working, or you came late from work and you cannot focus and you have to go to sleep or something, you should go immediately Friday morning or when the video will be available, which brings me to another point in here. It's a good idea you subscribe to the YouTube channel, because sometimes the video is uploaded, but I'm teaching another class, or I'm still working on some other fixings for the video, usually the closed captions, and sometimes refining things, and actually writing the rubric for that specific discussion that ensues. So I still I'm not going to post something while it's not completed. So by that time, probably you will have had a chance to go and actually watch most of the video, because some of these videos are lengthy. Some of them are way over an hour, so you probably need to get going on it. While you do that, if you are live, please make sure that any distractions such as a TV or a phone or something like that is away, because this is, although we are not live, we want to really be focused. Actually, the focus in here is far more necessary than if we are in classroom settings, because in the classroom setting, it's by itself conducive to learning. In here, you have so many distractions at home. You have things that you probably can be looking. So I suggest that you really set up a working area for yourself. And while we're meeting, you make sure that you're focusing just on your work at hand. Make sure you take notes, because if you don't take notes, after 10-15 minutes, you start to probably drift and start to focus on other things, and you have no idea what we're talking about, and it's really not good. So try to take notes, and if you're watching it recorded, though, there is a different technique, and that is you may need to probably break it down into increments, because this is not top, basically, #1 production that is Hollywood production or something. Keep it focused. The only thing that keeps it basically keep you focusing is actually by doing what we're talking about. If you're not clicking, if you're not writing, if you're not being actively participating in the class, basically whether live or recorded, you're going to basically fall behind, and you're not going to know what we're doing, and then at the end you're not going to come back to it. Now, even though you attend the class live, it's still a good idea sometimes to go back into the recordings. Let's say, for example, a point that we talked about, it's still vague to you, or you probably don't remember the exact steps that needs to be done. So in this case, you may need to go back into the discussion link and then find the video, and you know at that point where the discussion happened. If the video is 1.5 hours or 2 hours or 1 hour and 15 minutes or even 47 minutes. You know, the discussion happened, let's say, for example, toward the beginning. So you go toward the beginning, or skip all the way to the middle, or toward the end, and basically make sure you take notes. Since, like I said, I go an extra effort to do a closed captioning. It's usually for the people who need it because of some sort of an impairment. But even for people who have no impairment, sometimes I need it myself because sometimes there's too much noise around me, or I'm supposed to be in a quiet place, or I really don't understand what the word that was said exactly was. I mean, I probably was looking for a keyword, and the way it sounded, it's different than it's supposed to be. Especially me having an accent, it's probably helpful to watch those things and be able to really understand what those things. Science, especially physics, uses a lot of terminology, and you really need to be on top of that. So this is in general. This is basically what we're talking about. I know for some of you it's a repetition, but the others it's new to them, so it's fine that we can go through this again. Okay, let me talk to you guys about the syllabus of the class. Before I talked about the syllabus of the class, there is an assignment for you guys. I want a confirmation from at least one person that you guys are looking at my screen in here that says Physics 11 Fall 20. Okay, very good. So if one person sees it, that means everybody else, unless somebody is having a problem or something. So I just wanted to make sure that at least one person sees it. That means I'm sharing my screen. You really have to catch me right away, because I sometimes fall into that. What I'm thinking, I'm sharing my screen, but it turns out to be I probably forget to do that. I'm talking and talking, and after 5-6 minutes before somebody tells me, hey, we're not sure what you're talking about. I mean, we don't see what you're seeing. And that's bad. Okay, so we really need to catch that right away. Okay, so there is some working basically protocol that we really have to develop from now on, that you really have to make sure that to fix things. Okay, so this is your prompt. Again, for those who are taking Physics 10, they have a different prompt. For you guys, it's this one. So you're supposed to look at this, read it basically, and you need to tell me something about yourself, how you want to be basically addressed, the preferred name. I go by DJ. I already sent you guys, excuse me, at least 2 emails in the past. One of them, I think the week before school started. One of them was the Sunday before Monday, when the school actually started. And so you know enough about me that at least that I have been teaching this subject for a long time, so I should not have difficulty with the key concepts. We may run into a problem with the technology, which is another problem, but that's something that we should address and try to fix as much as possible. So that's basically as far as I am concerned. Now, like I said, you have this assignment that was originally had a different due date. I had to change it because of the fact that this is our first meeting, actually. This is when we're first meeting. So there are 2 steps in this project, in this discussion, basically. The first one, like I said, is due by Tuesday, September 1st at 11 o'clock, midnight. Just before midnight, I should say, 11 p.m. And basically, tell me about yourself, how you want to be addressed, and also a picture of yourself. It's very important to include a picture of yourself, so that to attach, basically to append a human element to a name, because if you're discussing something with your peer and the person only talks to a name, sometimes we forget that there is actually a real person behind it. And you too, you would want to see that the people that you're addressing, whether instructor, whether instructor is no problem because you guys are looking at me right now, but other peers also have actually they're real people behind the scene, and they have dogs they like, or cats they like, or something. Okay. Nowhere, you have to stay. If you are in lecture, where this is just the intro, okay? We have to talk about the lab today. So Kyle is asking, do we have to do this again? Oh, about the activity, yes. I mean, probably the people who are in your Physics 10, they know more about you and things like that, but there are people in this class who don't know you, so you have to do this, even if you are in Physics 10. That's a good question, Kyle. Okay, I'm sorry, I thought about the, the meeting today. It can be, but was it the same assignment? I thought for Physics 10 it was different, no? If it's the same assignment, it's fine. Yes, it's similar, but the other one was slightly different. Okay. So anyway, the point being in here is you need to. Yeah, the other one was about the flat Earth. This one is different. Is a different topic. Okay. So basically, the topic is the one that you're supposed to Google and basically look at the minority. Please stick to physics and chemistry only. Do not go to biology and other fields. I don't know much about those things to honestly I mean, you might be talking about things in biology and terminology in biology that is not really something that they can understand. But if you bring somebody in physics or chemistry, a Nobel Prize winner, from who is a minority, basically, doesn't, as long as it's not for the mainstream, that's fine. Go research it, find it, and what that person did, a little bit about their what they did, and a link to what you found. Okay. And an interesting thing that probably relates to that. Again, we have a problem. You know, physics is really suffering from a huge disparity in terms of representation. There is only one dominant group, basically, that dominates the field. And diversity is critical for the advancement of science in general, for the advancement of society to be in general. Because if me and my buddy sit together and start talking back and forth and basically do things and don't include somebody else, it's only our experience and our basically that is going to contribute. But if we bring a third person to the discussion and see it from their perspective, it's going to open a new perspective that we did not have, and we could advance the topic further and have enrich it more and so on and so forth. So the physics is really hindered in that sense. Physical sciences in general are hindered in that sense. We really need the contributions from different members of society, from different backgrounds, from different basically experiences to enrich the topic. So that's really the purpose of which. So diversity is critical, and I'm really a firm believer in it, and this is why I chose this topic for you guys. Hopefully you will find an interesting stories in there to relate to your peers. And by Friday, September the 4th, you're supposed to reply back to your peers, basically. You need 2 replies. Please choose peers who did not really have much contribution, especially the people who came late, because the person who posts first will have a lot of replies because everybody sees his or hers, and then the person who submits last will have basically nobody basically interacting with him or her. So try to look through and see which person did not have much interaction and try to interact with him or her. That way you build basically communication skills with people, and there is already in this module, there is already a rules on how to address people and how to basically behave when we are online and things like that. We have to be respectful and mindful of the fact that there are real people behind the scene, because sometimes when we're typing, we get excited and we forget the fact that we're dealing with people. If we're doing face-to-face, we have tendency to be more polite and more basically respectful, and that's the purpose of that unit there, so that you guys have that in mind all the time. This is really the goal of this one, is to establish, first of all, report and rules on how to engage one another. Again, this is graded. The rubric is here. Click in here and show rubric. So you're going to see the rubric. How much would you get if you do all of these things? By the initial basically deadline, you'll get the full mark. If not, you're going to get this mark. As a matter of fact, you can grade yourself. Please ignore these dates, go by these dates, okay? The rubric has the dates from the previous assignment, assuming that we met from the first or second day, and that did not happen. So the deadlines are here, not on the rubric, okay? And I'm going to change this rubric, as a matter of fact, okay? So probably I should do it now, can I? Yeah, let's make sure that this date, the initial date, is actually, if my mouse can is 9/1, okay? Why it's not changing? Oh, sorry. I need to change it this way. 9/1. So this is the first day, and again, this is the second date. Is 9/1 again. It has to be between 9/1 and 9/3. Okay, date. And finally, this one is 9.3. Okay. So good we did this together, at least to catch any mistakes. So this is due by 9.3. This is due by, what is it? 9.3 or 9.4? I'm sorry. Did I say 9.4.3? Why did I say 9.3? It's 9.4. You guys need to correct me, okay? I make a lot of mistakes, okay? So you guys need to be aware of that. So this is 9.4. 9.3 is a Thursday, isn't it? I thought it's a Thursday, Amanda. Because this has to be by Friday. Okay? Okay, so we fixed the rubric right here and there, okay? So we didn't have to wait for it and then I forget and then it's going to be confusing, okay? The rubric is fixed so that you guys have, you should go by the rubric. Whatever you see in assignment, look for it, okay? It's really critical because I don't like surprises and I don't like to surprise people either, so that you know exactly how you're graded. As a matter of fact, like I said, you could grade yourself. You could just go and look at the deadline, look at the components. If everything is there, you should give yourself a grade that is there. If something is missing, you know exactly how much you're going to get. Or at least you can grade that thing yourself. So you don't have to have me grade anything for you for that matter. Okay, this is one thing that I needed to bring to your attention because it's due Tuesday, so I need you to really look at that in here and make sure that you have that. The other thing also, when you come into to Canvas, it's going to take you to the home. And this, I need you to pay attention. This is my contact information. The preferred way of contact information is through the inbox. Now, if you have a question about this recording, or about this class, about this lab, please do not ask it in the inbox, okay? If you have a question about this discussion that I was just showing you, please do not ask it in the inbox. Try to ask it, unless it's specific to you, unless it's personal, and you don't want really people to get involved with it. You're having personal difficulty with some technology or something. I mean, technology is not really personal, but let's say, for example, you have some personal things, that's fine. Then you can ask it in the inbox. If it is related to the topic, I would recommend as much as possible to ask it in the discussion itself. For this class, there will be a follow-up discussion, and there will be this video recorded there. If it's a general question, hey, you told us to do this, but it was not clear in there, so just ask it there. Now, if somebody else probably can intervene and interject and say, no, this is actually how it's supposed to go, that's easier and that enriches the topic. Remember, the purpose of the first prompt really with the first project for you guys to do discussions is to establish that kind of cooperative basically work. That's exactly what we want to do. The link, for example, on GeoGebra is not working for you. That is where you go and ask that question. Maybe you're clicking on something else or you're getting something else or something is not working for you or something that needs to be done. You forget to change the mass or change something and then all of a sudden the data is not changing for you. So this is the place where to go and ask. Do not ask it here. That's a good idea to ask it in the discussion for this lab, so that if I'm not available, and weekends I'm not, I'm available usually Monday through Thursday, I usually try to respond right away, unless I am teaching a class, like right now, for example, with you guys or somebody. A lot of people send me messages during that time. I will not be able to answer it. Or after that, I mean, on Friday through Sunday, I may be outside. I may be basically doing something else, playing soccer or driving somewhere or doing something like that. At that time, I don't have even my phone with me. So at that point, somebody else might intervene and basically respond to you and give you an answer. That's probably, and maybe later on I to help you with it or something like that. And if you have a specific question, it may turn out to be that it's not only you who are having problem with it, but everybody else. So if somebody answers it or I answer it, it benefits the group. Instead of me responding to each and every one of you separately, it would be helpful to answer it once, so that when you go and look at the discussion and you try to ask the question, hey, the question was asked already and it was answered, okay? Or you go there and you find somebody asking another question and you yourself actually will intervene and help them. Does this sound to be a working plan to you guys? Okay, very good. So we have to have that hopefully as much as we can as we go along to establish this rule. Especially with the lab, there is a lot of doing. So there is a lot of technical questions about this. It's not like the lecture, for example. It's you go and look at the book and you find the answer. This one, you may go look for somewhere and you don't find the answer. So there will be probably a lot of questions. So please do ask them in their places there. Okay. Again, this is my contact information, my email, just in case if for some reason the inbox did not work and the discussion did not work. So you can still reach me by email. The last thing you can do is text me. Okay, this is my personal cell phone. Again, it's a Google number, but you can text me and I should get it from you. And this is usually during exams. For this class, there is only one exam, and that is the final. Okay, that is the only time probably I would think that probably you will be tempted to use that texting feature. Otherwise, I would expect this one not to be used. But just in case, it's in there too for you. Okay, I know we are live right now, and it's going to go on YouTube, and the rest of the universe will have this number. That's why usually I check to make sure that I am getting it from people that I know. Okay. Anyway, this is the general policies. In terms of really what you need to know is everything is going to be online. There is no paper basically work for this class. The only paperwork for this class that I have noticed in the past happening is some people, what they do, they print the lab report form, which they really don't need to, and then they scan it or take images off of it. That is fine. Please try to optimize the images if you can. If you have a camera or if you're using your phone, try to lower the resolution a little. Do not leave it at max, because one page could be several megabytes, and trying to upload it later on, and you have a deadline, 11 p.m. it's due tonight, and you start uploading at 10:47. And you notice the first page is taking forever to upload. By the time you are at the 12th page, probably it's already past midnight. So you already have submitted your work late. If you optimize the image, instead of it being several megabytes in size, maybe a few hundred Ks or even less, then it's going to go faster. So if you come in 10:47 and trying to upload things, maybe you do it just in the nick of time. You have your assignment basically submitted. Try not to do that. It's a good idea, good practice, to put a personal deadline to yourself, not to submit anything past 6 p.m. because to basically avoid any kind of problems with the internet or something like that. Try to say, okay, yes, I know the deadline is 11 p.m., but I'm going to make sure it's up in there and working, and I'm going to go and test it and check on it to make sure that it's there on Canvas for me so that I don't lose grades. I do not accept late work, so that you guys know. So if something is late, you lost it. So try not to do that. I dropped the lowest grade, which is actually catch up for that, for the labs only. So you can have that thing there, so that if it happens to you where you forget to upload your work, or you did it past the due date, understand that assignment is going to be graded with 0, basically. You're not going to have it. As you saw earlier, there is deadlines for everything in there. So if you miss that, that's it, that's gone. So please don't do that. Try to stay on top of it by being proactive, basically, by making your work uploaded on time. Yes? Correct? Very good. Again, you need a software which is actually this first assignment. I stated what it is. You need Adobe Reader. The PDF file that I gave you this morning, the first thing you really need to do to it before you do anything is download it onto your computer. Do not leave it on Canvas. Download it first on your computer. That's it. That's your first task before doing anything, before reading it, before doing anything. Download the thing on your computer. Then open it with Adobe Reader. The way you open something with Adobe Reader, or anything for that matter, is you right-click. When you right-click, you say open with Adobe Reader, okay? Find the Adobe Reader as part of your things. If you're not sure about that, please let me know. I will send you links on how to do this so that you open a file with specific program, and that way you open it with Adobe Reader. The reason why I say that is because this is a fillable file. It's a form, actually. It has fields that you can fill manually. I know, especially now, Microsoft Edge, and to some extent fails those files. I think Firefox fails at it. I think, I don't know about the other one, the one from Apple, Safari, I don't know how it does it, honestly. Chrome also tries to fill it. Do not rely on any of those browsers. Use the reader. PDF was started by Adobe, the company Adobe itself, or at least that's the one that popularized it. And they are the best at it. And the file itself was actually created by Acrobat. So it should work only exclusively 100% flawlessly with the Adobe Reader. So get that software. It's 100% free. When you go on that link to get the file, you will find so many other things that Adobe wants you to download. Those you don't need to. Somebody from another class mentioned that those are bloated softwares. They are. One of them is Chrome. So if you don't have Chrome, you probably, if you think that you need it, go ahead and download it. But the other one were a couple of antiviruses and some stuff that you really don't need. So just ignore those. Now, if you really think you need them, just go ahead and download them. But the key thing in here is the reader. The others are not really needed unless you want them. Now, once you download the file onto your computer, we're going to talk about this one. Then you're going to go through the instruction, do everything the instruction is telling you to do, and then go to the form and start filling the form. The first thing you should do is put your name, okay? And then answer the questions per the rubric. The rubric also states exactly how those things need to be answered. So try to answer them and basically step by step until you're done with that. So that's very important that you have to do that. Once you fill the form, once you're done with it, a critical step in the process is to actually save the file, because sometimes you forget to save it and you close it and it's not saved. You come later on to it and it's completely blank. There's nothing in it. So that's disaster, because all of that work is gone for nothing. Now save the file. Open it again just to make sure it still opens, because if you think you're done with it when you saved it and you upload it to Canvas and you think that, okay, I did my job, so I can go and have some coffee and things like that, and then come the deadline, I look at the file and I send it back to you and I tell you it's empty. Look at it. And that's a disaster, because you wasted so much valuable time doing something, and whereas you should have gotten probably the full credit for it, you're not getting anything. So open it again just to make sure everything you did is there, okay? Then, if you have to change something on it, again, don't forget to save the file and open it again to make sure that it's still there. The new changes are still there. Then when you're all ready and said and done, you go to Canvas. Inside the assignment itself, there should be a link for submitting the file itself, okay? Browse to it, upload it, and you should be fine, okay? So I'm telling you this thing because this is really a technical issue that sometimes people run into it. In terms of technology, this is the major thing in terms of requirements for my class. Other than that, you should be fine, okay? All of the other stuff in here is standard things. This is how this class is graded. The final is out of 10%. Now, a word of caution for those of you who are sitting in my other class, Physics 10. The final also is on the same day, okay? The final on this class is also on December 10th. Now, the assignment for the final of this one will be given ahead of time. So you'll have ample time to submit this final before this date, okay? If you're thinking that the other final will intervene with this one. So you can submit it before the deadline on this one. You can submit this one, Physics 11, before the one for Physics 10. Okay, that's what I recommend that you guys do. For those who are not in Physics 10, just basically go by this deadline if you like. There is no problem with it. Again, for you too, the assignment will be submitted in the same time. So you may choose to submit it on or before that deadline, okay? So again, The final is going to be like a take-home where you're going to do all kinds of questions and answer them and submit them, just as much as like you're going to be doing your lab reports. The actual labs, they're worth 80%, and the participation, again, is weighted 10%, okay? This is basically the labs that we will try to cover, okay? This is not guaranteed that they're going to go in this sequence because of lack of resources. So if we do all of them, we're in great shape, okay? Today, we're going to start with motion. Then next week, which is the 3rd, we're going to do with vectors and equilibrium. And then we're going to go by. Don't forget that there is a holiday in here, and everything else should be fine, okay? The 3rd is actually when you get your assignment for the final. So by the 3rd or the 4th, you could submit your assignment, okay? You don't have to wait for the final in here for the 10th, okay? So that's in a nutshell basically what the syllabus is for this class. As I said, there is already a couple of things that are due in here, and one of them is this one. So this is the lab report file. I'm going to open it and see, okay? So this is the assignment. Does everybody see the assignment for this lab? Okay, very good. So we're on the same page. Here is what I was talking about for this lab, for today's lab. Again, all of this is stated in here in step by step. The first thing I would do is download this thing, right? Click on it, save link as. I'm using Firefox. Then I choose a folder on my computer. Try to organize all of your labs in specific folders so that you don't, not every day, so that all the time you can find them specifically where they are. You don't have to be wasting time looking for them here and there. So once you save it, it's going to be a PDF file that you're going to go and open. So the first thing is download the file, the lab itself. And then do not open it with any browser. It doesn't matter what the browser is. If you double click on it, sometimes the browser will take over and opens it for you without even you asking it to. So if you do that and you fill it and you're done with it, it's not going to save. There is something they used to say, at least in terms of technology, is that browsers are actually stateless. HTML is stateless, meaning that it doesn't save by itself. It doesn't keep state between state and state. You have to use cookies and things like that in order to transfer data between a session and session. And here, download the thing. Now it's on your computer. Yeah, you can make whatever changes you like to it since it's in your computer. Okay? And this is the stuff that I was talking about in here, the steps that I was saying. The assignment is due Thursday. This is Thursday, okay? This is due Thursday, a week from today. All the labs will be due a week from when they're started. So today we're starting this lab. A week from today is September 3rd. By 11 p.m., this lab is going to be due, which means that the next lab is going to be due by September 10th and so on and so forth, okay? So all the labs will have a week window for you guys to complete and finish them and submit them. For this specific lab, here are the rubrics, okay? Again, you can just go by this one and see exactly, if you do everything, you should get a total of 56 points for doing this lab, okay? You miss one thing or the other, and you're going to basically know exactly how much you missed. You miss in here, for example, the objective has to be stated correctly, states the objectives and goals of this lab. So what is the purpose of this lab? If you read the instructions step by step, you should see basically what we're trying to achieve from this lab, okay? Sometimes we say, sometimes we don't, but you should see exactly what we're trying to measure from this lab. For example, in this lab, we're going to be measuring the velocity and the acceleration and how the acceleration and the velocity are related to one another. So you're going to basically put that in your own words in here, okay? That's the objective. You don't need numbers in here. So somebody asks, okay, what's the difference between the objective and the conclusion? They're almost identical. I'm not saying they're identical. The conclusion relates back to the objective, how the objective was met. Then there are numbers, usually data, supporting that conclusion, okay? This is like the hypothesis, and this is like the result. That's why there is more weight to the conclusion, because of the fact that it has more sentences requirement, actually. In terms of sentences, 2 or more complete sentences a yes or no, or this or that, without a verb in a sentence is not going to be complete. So you really have to use complete sentences, especially in the questions in here. It asks you a question, and you say yes, or no, or okay. That's not acceptable. You have to really use complete sentences when you're answering the questions, okay? So, and here, the requirement for here must be 3 or more sentences. You see here? So that's why this one weighs heavier than the first one. Then all the questions are worth 2 points if they're using complete sentences plus proper use of scientific terms and units. If the distance is measured and the question is asked about the distance and you find a value, it has to have a unit. If it's centimeter, stated. If it's meter, stated. But if you tell me the unit is 2, that is not acceptable in a lab environment. You would walk to the store tomorrow and tell them, okay, I need 12. You go into a gas station, for example, and you're doing the line and it's your turn, and you tell them, okay, give me 22 or 13. It doesn't matter what the number is, but the point is, if you don't tell them what comes after the number, the person would not understand what you're talking about. 12 candies, 12 whatever, donuts or something like that. So you have to be specific. You have to attach to it unit. Physics is all about measurement, and measurement is comparing to a standard, and a standard is the unit. So if you're measuring distances, it has to be a meaningful distance. If it's meter, it's meter. If it's centimeter, it's centimeter. So if it's a mass, it's kilogram. It's a force, it's a Newton. If it's a velocity, it's meter per second, and so on and so forth. Missing a unit will take you from this level to this level, okay? Put you here. Missing everything will put you there. So that's basically how this thing is graded. So you can look at your work or somebody else's work and know based on this rubric how much grade you're going to get. The difficulty is with the tables. This specific 2 tables, they have 2 tables in this lab, each and every one of them has 18 data entry. Each one of these data entries is worth 1 point. So that's why all fields entered correctly, you get 18 marks. Miss 1 or more, but less than all, basically, if you can only put 1 correct, you're going to get 10 points. Miss them all, and you're going to end up in here. So this weighs heavily. Data collection is very critical, so you have to make sure your data is transposed correctly into here, okay? And calculations are done, so you need to know how to do these things. And then we go into this one in here. So that's enough about the rubric. So we know how the rubric works now. Any questions about the rubric so far? No? Okay, very good. Down the road, you might run into some issues, so it's fine. I mean, you can answer them, okay? So it's okay. So if right now, for example, there is something we don't see, but down the road we discover, please go to the discussion session of this one, this specific lab, and ask it there, and hopefully we will answer it like I said in the beginning. We're going to download this file now. I'm going to follow my... Okay, I did something. Okay, when I clicked on it, I don't know if you guys see this thing or not. It says open with Firefox. I don't want to really open it with Firefox. I want to open it with Acrobat Reader, okay? So it's going to open it for me. I'm going to stop sharing the screen because I'm sure you're not looking at it right now. I'm going to go now and find it on Acrobat. Okay, let me look into the page per page thing in here. Again, the first thing I would do in here is put my name. Okay, that is me. Your name is going to be not this one, of course. So you have to put your name in there, okay? So you're going to put your name in here. The second thing is read through the instructions. It tells you specifically what the introduction is. This is actually a good starting point to formulating your hypothesis or your objective, okay? You have to understand what this lab is talking about in here. Then it goes into the theory, basically. You have a Cartesian coordinate system. You have examples in here of points. If this were east-west, how we describe them, and this is south-north, and so on and so forth. So we're using Cartesian coordinate system to present points in space. And I assume that you guys are familiar with it. Yes or no? Are you familiar with Cartesian coordinate system? Okay. Okay, so basically, let me explain a little bit what this is, okay? Every point, let's say for example, this is the plane with which we want to find stuff on it, okay? The plane is a surface, okay? And the surface can be represented, or every single point on the surface, like this point, or that point, or this point for that matter, can be represented with 2 points, namely, how far it is. Okay, that's fine. It's how far it is if I travel on the x-axis and the y-axis to find this one. So this point will have specific units in the x-axis and specific units in the y-axis, okay? So that is basically what the Cartesian coordinate system is, okay? So that's basically a representation of points in space. Okay, that's fine. So let me undo that quickly, if I can go back into the page now. So that's in a nutshell with the Cartesian coordinate system. It's every single point in space is represented by 2 points. One giving it its location with respect to the x-axis, and one is giving it its location with respect to the y-axis. On the x-axis, I have -3. On the y-axis, I have 1 for this point. So I have to travel -3 units. So that means I have to go in the opposite side by 3 units. And I have to go +1. That means I have to go 1 to find this point. And the same thing for the other 2 points in here, the green and the blue. So that's what the Cartesian coordinate system, and we're going to use that basically trying to describe vectors. Because ultimately what we want to find is the speed and the velocity of an object. The rate at which the displacement is changing with respect to time is what we call velocity. The rate with which the distance is changing with time is what we call speed. Speed is a scalar expression of the velocity, okay? So this is a vector velocity. This is a speed. When you see these symbols, I mean absolute value. That means that ignore the sign. Whatever ends up being, just ignore the sign. If it's -20, just take the 20. If it's +20, just take the 20 without these signs in it. So that's basically in a nutshell what this thing is. And so you're reading through this one. I crossed this part in here because this is actually an actual lab that we used to do in the lab itself. So I modified this lab slightly, and we're doing an online simulation for it. So I'll show you exactly how that online simulation works in this case, okay? So this is a lab that we will do in the lab, in the physical lab, had we actually met there and talked about it and go through all of these things in here. So I'm just going quickly through and here I'm assuming that you guys will try to understand what the velocity is, what the acceleration is. Try to understand what the introduction meant in here. One of the oldest and most fundamental problems is the motion itself. So to describe motion accurately, we must be able to precisely define the object's position in respect to it. So that's the purpose, is to study this motion, and motion is velocity, really, okay? Now comes my objective, okay? It's a good idea to ignore the objective for a moment. Try to go through the lab itself, okay? Try to understand what we're doing in here. And this is usually the experimental procedure. Again, this is part of a lab that is actually done in classroom. You will have 2 photogates. Photogates is like what you do, for example, like there is a beam of light that goes between the 2, okay? There is a beam of light, and if somebody breaks that light, they read that. And if there is a continuous read, so when you go sometimes in some doors and some businesses, there is a bell that rings, or because you broke that signal, okay? That's exactly how the photogates work. So there are 2 of them. And there is a car which sits on rails, and the rail is inclined a little bit. If we don't incline, it's not going to move, okay? The height with which it's going to go up in here in the lab is about 8 centimeters. This whole distance from end to end is usually 1 meter for the rails, okay, where the lab where the whole thing sits. From this point to this point is about 60 centimeters, okay, between the photo gates, the distance between the photo gates. You let go of the car, and it's going to go up through. There is actually something that is going to block the light for a few seconds. Okay, as it passes through. Initially, it's going to take longer time than when it passes through the second photogate, because of the fact that it has gained more speed then. So it should take less time when it goes through the second photogate than the first photogate. So that's how the lab works in here. And you have to make sure that only the top, it's called the picket fence, actually, the one that they put on the cart in there, that breaks the light. Because if you bring this way down, it's going to read the entire car. Okay? If you bring it too high, then it's not going to see the car passed, and you're not going to record any time. So in the lab settings, usually you have to tinker and play around with this up and down. You make the car go through it and see if the light breaks or not. If it breaks, that means you're good. If the light doesn't break, that means it's still too high. You need to bring it down. So there are some adjustments you have to do in the actual lab in order to do this lab in here properly. Then this photogate will give you a time reading for how long this one took to go through it. Remember, if I can measure the length of this one and take the reading of the time, I have found the velocity with which this object went through at this point. The same thing in here. This will give me second time as it goes through it. So I'll have two times in here to read from the photogates. In the same time, the lab settings actually has something else. I don't know if you guys talked about or not. I don't think I talked about it. What is it? Here, there is this RMS in here, which is a rotary sensor. That one will give you another set of data, basically the actual speed as a function of time for the entire car as it's moving around on the inclined plane. So that's going to give me that speed, and also it gives me the acceleration. So I'll have two kinds of values in here. I'll have the speed and the acceleration from this one. Of course, my goal is to compare. I have two ways of finding the acceleration now. I can find it directly from the rotary center or the RMS in here, or I can find it from this measurement of the velocity, which is this time. When it divided this distance by this time, that's going to be a higher velocity because this is a shorter time than this velocity, which takes longer time to pass by, which is the same width basically passing through it. So this velocity minus that velocity divided by the time that lapsed, because I will have also the reading the time between these two, T3. So there are three times in here. There is T1 for when this passes through the first photogate. There is the second time for when that one passes through the second photogate. And there is the time for the entire trip of the 60 seconds. So I have the final velocity. I have the initial velocity. Plug them into my expression in here. V final minus V initial divided by the time. It's already give me the time. Okay, I don't have to worry about that. It's going to be T3. From there, I'm in business. I have my acceleration. Compare that to another set of accelerations that I will get from the rotary sensor. Yes, T3 is the time between the two photogates for the entire 60 centimeters. Jose, you could have asked this one, not necessarily private. Okay, that's fine. Basically, Jose is asking, is the T3, yes, it's the entire 60 centimeters between these two photogates, basically. I don't think that the photogates are represented in this picture, but they're represented in this diagram here. So that's the 60 second. That's what needs to go into the denominator in here in these expressions. Let's look at this data in here. So the D is my 60 centimeters, basically. So that's going to be written in stone, unless we change the distance separation between the two photogates. L is how thick is that one. With a ruler, in the lab, you actually measure it. But in here, it's going to be given to you, okay? 4 centimeters, 8 centimeters. I really don't know exactly the number, but you will get it. Then, when you do the actual simulation, it's going to give you T1. How long did it take for this one to go through this? That's T1 to find V1, okay? Which is this length divided by this time. That's V1. It's a formula in here. So all I have to do is take this one, make sure it's in meters though, okay? Because it's going to be in centimeters. So make sure you convert that in meters. Or if it's in meters, you're in good shape. Put it in meters. and the time is going to be in seconds. So the unit for velocity is in meter per second, and here you plug in the value. You do the same thing now for T2. It's going to be less time, so this number will be higher. So it's going to be moving faster. The average velocity would be just this distance, which is 60 centimeters, divided by T3, the time that elapsed between it. This is the average speed of the two, okay? That's the V average. And then the acceleration is the difference between these two velocities divided by T3, okay? So you should be fine. I mean, just following the steps, you should be good. I mean, the only question right now, where am I going to get the data from? This is without weight, without the 500 grams, because you're going to at some point add 500 grams to the lab, okay? And then you do the second data with the weight on it, with the 500 grams now added on top of it. In the actual lab, there are some weights actually put on the cart in there, okay? Each one of them weighs 250 grams, okay? There are questions in here that you, after you look at the data, you're going to answer them, okay? Let me go to the second table now. The second table relies on the first table again. And at this point, so basically you have the velocities, you have the time. Okay, I think this one is not fully developed yet, okay? All of the experiment right now is on this one. So for right now, I need to look at the actual lab to make sure that this is accounted for. If I make changes to it, it's going to be on this link, okay? So here is the link where you get your data. So I'm going to click on the link. This is the link that where you go and collect your data. So I'm going to click on it and stop sharing the screen and go and share with you the screen where I'm going to get the data from. Okay. So when you click on the link, you're going to get into this page, okay? Let me try to make it smaller. My screen is not responding. First of all, I need confirmation that you guys are looking at this. Okay, good. Okay, for some reason, my screen is not showing me the whole thing in here. Okay, let me see if I can change that. Okay, again, I can probably try to minimize it from here. No. Okay. If for some reason I can't get to T3, I don't know if you guys can get to T3 or not. If you don't, please let me know. Probably it's something that is. So I just added the mass of 500 grams now, okay? Let me remove the mass in here and go back to the settings in here and collect data. When you come in here, make sure you have this one is 0 and you make sure you collect data in here. For some reason, it's not clicking. Okay. I clicked too many times. My screen is not responding. I think it's due to this Zoom thing. Okay, my screen is slow. I clicked a million times, so it gave me a million pieces of data. So it's got L is 4 meters, 0.04 meters. That means it's 4 centimeters. Okay, and D is 60 centimeters, which means 0.6 meters. So it's already converted for you. T1 is 0.41 seconds. Again, it takes longer for the first time through the first photo gate, and T2 is 0.05 seconds. So all of this data is going to go on my tables, okay? And T3, I don't know if you can see it or not. Let me see if I can unlock it. Okay, I just unlocked it. Let me lock it back in. Okay, and T3 is 1.63 seconds. So that's my data in here. Jeffrey, is it fixed now? Can you see it? Okay, very good. So that's basically how you get all of your data. And now there is another thing actually that you're going to need for the second part is this actually graphs in here, okay? It's already done for you in here. So the first graph in here is a fit of the data, okay? It's not exactly linear, but it's very close from a linear. Those are the data in here. This is the set of data. This is the velocity as a function of time. So you can answer the questions based on this graph, based on this data in here. That's the next questions. Also, this is the acceleration as a function of time. You can see hardly it's not constant, but on average it's constant. And this is the best fit this program is giving you. If you don't trust it, please let me know. We can export this data and you can put it in Excel, and you're familiar with Excel and how to use the fit function. They call it the trend line in Excel. And I think also Google, if you guys don't have Excel, you can use the other one from Google. What is it called? Open Docs, no, Docs, I think they call them. You can use that too, and it also has the fit function. I think they call it the same thing, trend line. In here, it's actually a fit function. Actually, this is far more advanced than Excel or the other one because it requires a lot of programming at the end. Now, this is without mass. I'm going to do a critical step in this one. Please remember it, okay? When you add mass, you have to collect the data again, okay? And you might click on it twice, okay, to get the actual numbers, okay? The data has changed, and you're supposed to answer questions related to that, okay? When you add mass versus when you don't add mass, what is the things when it? This is with the added mass of 500 grams. Again, the length L did not change, is not gonna change for this lab, because again, it's a physical property. This is something that you have actually in the lab too. When you go to the lab, you have one in there, okay? And the distance is, you fix it. And the lab actually, you fix, when you're mounting your photo gates, you're actually putting them at specific distances yourself. The instruction in the lab says to put them at 60 centimeters to have meaningful data for you to interpret. If you put them too close, you will not have enough data in here to interpret what's going on. So basically, you don't have enough difference in velocity. You will have a lot of errors. If you put them too far, first of all, you need some room where to put the car from inside, and you also need to catch the car before it hits the end, okay? So you need to leave some leeway. The whole thing is about a meter long. So 60 centimeters, you leave about 20 centimeters on one side and 20 centimeters on the other side. So this is the number for the lab. I mean, you can change these things. This is fixed by you, and some of it is limited by the devices that you have, and some of it is limitations by the settings of the lab. So this is basically trying to replicate as much as possible what you would have done had we met in the actual lab. You have the link on the PDF file. It's going to generate the data for you, because even if we are in the lab and you connect everything, you connect all of the wires, tells you to connect this one input 1, the other one input 2, and all of that, all you're going to get is the same data. Okay, you're going to get the same data. And there will be errors in that one, and there will be errors in this one. I made sure of that this is really replicating what you would do in the lab had you been in there in the lab. There will be no exactly 100%. No, you don't need to. V is asking, you guys don't need to ask. This is a good question to ask actually in general thing. You don't need to convert from meters to centimeters. I know the table is giving you that, but make a mention on it. Make a mention of it, okay? Make sure that you're aware of what you're doing, okay? Oh, how did I pull it? It's actually I'm going to because I'm the one who designed this actual file itself. This is actually on my own account, my GeoGebra account, so that you guys know. So all of these things is done. So I'm going to position things around and resave it. So next time when you come back, you don't need to worry about that, okay? Because I think it's too high at this point. It's really it's going to probably, for some sets of data, it's going to mess up your table in here, and you're not going to be looking, I mean, your actual lines, and you're not going to be looking at it. But this is just quickly so that, because some people were having difficulty looking at T3, so I just pushed it quickly in there, okay? Again, I'm going to re-edit this one in here to make sure that this looks the way it's supposed to look like. And if you have difficulty with it, or if it's not responding to you the way it's supposed to be responding, or you're not getting any data, the key thing about this whole thing is, before you do anything, please, when you come in here, I'm going to refresh the window. If I refresh the window, it's going to probably go back to where it was in here, okay? If I can go back, reload. It's going to go back to how it was before, because when I saved it, I think I saved it, no? I think it's recognizing my account too. So it thinks that I'm the one who made changes to it. Anyway, I'm going to fix it, okay? I'm going to fix it so that this is exactly what it's supposed to be. You see, it went back to what it was. Okay, it went back to what it was. So again, I'm going to fix it so that this does not happen to you. Okay, so this will be in the place where it needs to be. Any other questions? Because you should have everything in the lab, the questions. Let me stop sharing the screen and go back into the PDF because that's exactly where everything is happening, where all of the fun part is happening. So the questions. So the first one, I hope that you guys understand what you need to do. Try to understand the lab, try to do the whole lab, then come back if you like and basically think of what to say in there, okay? Then after you come to the question one is measurement of velocity was very different in the time before computer-aided data collection. Can you think of some accurate way to measure velocity that does not use a computer? Okay, how would you use, can you find velocity? This is a general education question. You can go and Google it, do whatever you like, discuss it with your peers, email them, put it in the discussion board, basically ask there, okay? So this is, again, I encourage very much working together, okay? Okay, somebody, stopwatches, that's a good idea, okay? So you guys need to work together. I have absolutely no problem with that. As a matter of fact, you're encouraged to work together. And if you want me to facilitate that, I would be more than happy to do so. So this is not something that is going to be, however, when you're responding to this question, try to have it your own words. Do not copy somebody else, okay? Do not use somebody else's file and post it in here. Working together is one thing, but having somebody else do all the work and submit their work, that is different. That is a no-no, okay? So you have to put it in your own words. Again, don't forget it has to be complete sentences, okay? Sharing ideas with other people, that's great. That's exactly what I think we should do. But also, you have to have your own, you have to take ownership of it because down the road, you're going to look at your own work and recognize it. You don't want to say, who said that? Because it's not me, okay? And that's how I'm going to grade that too. So you have to be careful of that too, please. Working together is very fine. Somebody suggested stopwatches, that's fine. You can work as a team, yes. You can pick a friend and work together as long as you are not together in the same room because of COVID. If you can work together, that's great. Okay, that's fine. Please let me know so that I can facilitate it, okay? If 2 or 3 people decide to work together on this, I need to be aware of that. I don't want to see surprises that people are sharing data and then especially the data should not be the same, okay? Because each person should have their own data. This is basically your own collections, has nothing to do with, if somebody did the data collection 2 or 3 times or comes to the file 2 or 3 times, the next time they will find different sets of data. Because again, this is trying to mimic the actual measurement. When you go and measure something, usually you don't get the same thing twice because of the built-in errors in it, okay? As long as you take precaution in terms of safety, and as long as you're keen to the fact that I need to see different reports, I'm fine with that. Please tell me when you submit the report that you worked with so-and-so, so that there is no surprises and I will not be deducting points in there and saying that, oh, this is the report of the other person. Why did you have it in here? And both of you then lose points on that, okay? So, but working together, tell me up front, hey, I want to work with so-and-so, he's in my class or she's in my class and we like to work together, or with this group of people and we like to go together. And if you want me to facilitate it online, I'll be more than happy to do so. And whatever you guys come up with is great. That is actually my goal, is to have you guys collaborate together. And that's the purpose of those discussions in there and the initial discussion is things like that, okay? Now, is there a significant question two? Is there a significant difference between velocities at the upper and lower photo gates? Does this indicate that the car is accelerating? Why or why not? The only way to tell is by looking at your data. Is there a difference between them? Are they similar? Or are they, one of them is bigger than the other? Why do you think so? Okay, again, this is going to be coming from your own data. When you refer to data, please include the units, okay? Would your measured acceleration change if your photo gates were closer or further apart? Again, if you bring the photo gates, you're not going to do it in this. You cannot do this in the lab. Even in the lab, this question would be asked without actually going and bringing the photo gates together and see if something changes. No, the question is asked hypothetically, basically, theoretically. If you bring the photo gates close, would the acceleration change? Would the acceleration be different? Okay. So you need to research this one. Let me know if you have difficulty with this specific question. I need to be aware of it. And if you need help with it, I'll be more than happy to help, okay? Question 4. Looking at the plot, how would you describe velocity versus time? For the data that you choose to use table 1, how would you describe acceleration versus time? Again, you go back to this graph. You saw the data, how it looks like for the velocity. You saw the data for the graph for the acceleration. You should be able to infer what that is. Again, you're free to talk to other people, and please let me know, especially if you're using outside resources, like for example, Wikipedia or somewhere else, please include that resource in there. This is part of the things that you're going to learn in this class, is integrity. As a scientist, you have to really be honest in your reporting. If you found the answer somewhere else, use that as a reference, which is fine 100%. Again, there's nothing harmful in that. It's part of the learning process. But if you claim something and you don't refer to the source of it, and then it turns out that you get it from somewhere else, that is where it's a problem. That's where you lose points. Okay? Again, we're trying to instill this process in you so that you're building it as you go. Okay, this is where I found the resource. This is what the description is. Of course, if it's correct, you get full credit. If it's wrong, then we'll discuss that. Okay. Question 5, I'm sorry. Do your measured acceleration from your two plots agree? Because you have two plots, remember. One of them, you're going to find the acceleration one way, and the other one, you're going to find the acceleration the other way. So in here, actually, you can find it just by taking the velocity initial and velocity final from the plot itself, from the data of the plot itself, which you can look at it in the x-axis and the y-axis. And the instructions are in here. And the same thing, the first time when you took the first measurements, the second time when you take the second measurements, then you find the difference in velocities, the difference in time, that should give you an average acceleration. And the mean acceleration is given to you already in the plot. The mean acceleration, if I go back to, where is it? Do I still have it open, I think? Yeah, I still have it open. So let me stop sharing that screen and go back to that plot. So if you're looking at the x-axis, this is your mean acceleration, 0.32 meters per second, okay? This is, again, the coefficient, 0.29 meter per second. The coefficient, the x-axis is time in this case, okay? I'm glad that we're here. The x-axis is time, and the y-axis is the motion on the incline, okay? So this is the acceleration, the coefficient of the time. This is the acceleration, the average acceleration in here in this case, okay? This particular run. Oops, why do I open that? I'm sorry, am I sharing the screen or not? Did I forget to share that screen? Did I forget to share the screen? Okay, good. So let me stop sharing that screen and go back to the PDF file. So this lab should be complete. Then once you find the two, you're going to find the difference between them. And if you have difficulty in finding the percentage error, please let me know. I'll explain how that is done, okay? I probably will put it right down in there in the discussion board. How to find the percentage error. Basically, so that you guys know, because this is an experimental data for the average velocity. This is where you get the data from the graphs. And this is an experimental data also, you get it from another graph. Either one of them is an experimental data. Either one of them could be right or wrong. So what you do in this case, you take the difference between the two and you divide it by their own average, which is the sum divided by 2, basically. That gives you a number multiplied by 100. That is your percentage. So I'm going to show you the formula of how this works in the discussion, okay? You guys know how to do this? Or should I go in detail on how to do that? Okay, listen to this. How to find the percentage? Okay, I'll go by Amanda's request, okay? And Jeffrey and everybody else. Basically, this is a number. V average. I mean A average. And this is another number, A mean. Okay? You find the difference. That means you subtract the two. It doesn't matter which one is bigger. Just find the difference between them. No need to carry the sign. So if this one is 0.4 and this one is 0.3, the difference is 0.1. Okay? So don't tell me 0.3 minus 0.4 is going to be negative 0.1. No. We care only about the absolute value in here. We don't care about which one is which. Okay? Then to go back into that example, so the difference between 0.3 and 0.4 is 0.1. Okay? Now the average value between 0.3, I'm assuming this one is 0.4, I should say. I'm assuming this one is 0.3. Okay. Clearly, the difference between these two numbers is 0.1. Now, the average of these two numbers, I add 0.4 to 0.3, that should be 0.7. 0.7 divided by 2 is 0.35. So the average of these two measurements is 0.35. Now, in order for me to find the percentage error, I divide the difference, which is 0.1, divided by the average. 0.1 divided by the average, if I put it on a calculator, let me quickly find it in here, 0.1 divided by 0.35. According to my calculator, it should be 0.285. I rounded to 0.29. 0.29 is the ratio of these two numbers, okay? 0.29 is the ratio of these two numbers. Now, that is not how we express the error. We usually express it by percent. That means I have to multiply my answer by 100. 100 times 0.29 is 29%. So the error in this case is said to be 29%. The difference between if I measure 0.4 and if I measure 0.3, the error in this case is 29%. It's a big error, okay? But that's fine. I have to live with it. If my error is 29%, it is 29%. That means I was very lousy in my experiment, but that's basically, it is what it is. I mean, at this point, you cannot change it. If you collected the data and you are very careful with it, that is this value. So that's how you find the percentage error. Same thing with weight. This is without weight. This is with weight. The same process in there, okay? Find a velocity from the graph. It doesn't matter which, at some point. Find the velocity at a later time. Measure the times, the difference between them, and the difference between the times. Take the ratio. That's the average velocity. The mean is already given to you. Compare the mean to that, and you're in good shape, okay? Now, that's basically the second table. It's coming from the same set of data. There is no need to change anything on that one other than reposition that yellow box in there and put it in the proper place so that it's visible when you guys go online, okay? Yes, go ahead. You guys don't need, you can always unmute to ask question, okay? Is the question ready or not yet? Oh, okay, that's fine. If you're having difficulty with your microphone, you can always type the question, okay? I don't have a problem with that either. Okay, question 5. Do your measured acceleration from your 2 plus agree? And now with the 29% error, that's probably too much, okay, of a discrepancy, okay? So if they don't agree, then like this one in here, I found a huge error of 29%. Maybe the setup was not correct, or there was something with the setup, or probably I did not collect the data correctly, that I need to correct them or something like that. Again, this is an online lab. If we were actually in the lab, you might end up with the huge errors or less errors, and you need to really go back and fix them. For this one, basically you can't do much about it, but you have to. What would be an agreeable percentage error? Okay. Errors typically of few percentage, like for example, 2, 3, 4% are great. A 0% error is something that you really should approach it with a lot of caution. If somebody finds a 0% error, the first thing that they might be accused of is cheating. I'm not saying you guys are cheating or cheaters, but if a person doing a lab experiment and starts to play around with the data, move things around back and forth, and watch the error or recalculate the error so that you get the 0% error, this is dishonesty. You cannot do that. This is actually if we were in the lab and I catch somebody doing it, and it happened to me in the past where somebody actually was doing that, they will lose points in that lab, okay? So don't do that. So 0% error has to be very approached with a lot of caution. There was only one thing that I can remember in science where there was a match between a theory and the lab, okay? So 0% error is not acceptable. I mean, it can happen, and it's the rarest thing that it can happen, but it has to be approached with a lot of caution. Now, a percentage of few percentage points, it's fine. Usually that's typical. Some errors are due to measurements. Some errors are due to basically the device that measures the air is overheating or temperature is increasing, and all of a sudden it's not reliable anymore. So these things happen in nature, and when you're an experimentalist, you're dealing with this problem all the time, trying to minimize the error as much as possible so that your data is reliable. Whatever conclusions you draw from that data is reliable, so that you can go and replicate it and ask other people to redo the same lab, the same experiment, and they will end up with the same data. Now, usually once you are in the 15th percentiles and above, that means something is wrong. Something is really not great in there in the lab. Something that happened that needed to be fixed, okay? Again, like I said in the beginning, this is a simulated environment. So just to teach you about this concept when we are in real life. So if you find a huge error, do not really lose sleep over it. So just basically state the fact that this is an online lab and you can't do much about it. And if we are in lab, then I will ask you to fix it, because then you can lose sleep over it, okay? Question 5, do your measure, so that's question 5, that was the question. Okay. Question 6, does your measured acceleration typically change with the added mass? Again, you're going to look at the two velocities with and without mass, and at that point you're going to tell, okay, what happened? Why do you think the mass now all of a sudden has a role in it? Okay, I need you to think in terms of what's going on in terms of the car and the track itself, okay? Does this matter, that connection matter or not, okay? So again, if you're having problem with question 6, please let me know. So we covered all of the questions. The conclusion, again, you have to make sure that 3 sentences or more relating back to your objective that you already have by now. You know exactly what you're trying to do, and including data, including how much the errors were. I mean, if you're making a conclusion and you say you confidently think that you covered all of your objectives, with how much confidence? 15% error, 6% error, 21% error, or 50% error? If somebody comes to me and tell me I am 100% error, that something is going to happen, that means 100% in error that something is going to happen, then I know he doesn't know anything about that topic. You guys understand? Somebody comes to you with a huge error and tells you this is a statement, then you know. So this is basically why it's important to relate your conclusion, include the error analysis a little bit, talk about how much confidence you have in your data, and try to be as accurate as possible. The purpose of this whole physics class is to teach you this whole process. We're going to do a lab after lab after lab after lab, and we'll see this common theme repeating again and again and again and again, readying you for the final so that you know exactly what to say in the final, and you would have learned valuable skills. Hopefully, if you're an experimentalist or if you're going to conduct an experiment, you know the value of all of this data and how to collect it and cherish the data. Basically, the data becomes your guide. Basically, we are blind without data. The minute we have data, then we can see, we can basically try to analyze it and see what's going on. I'm thinking in terms of COVID right now. Scientists are working hard day in, day out, trying to understand basically what this thing is and trying to understand how to fight it. For that, they need to run experiment after experiment. think about the people who are actually not sleeping right now. I mean, scientists working in labs around the clock, trying to do something basically that is hopefully will save us as a main species, especially our lifestyle that is gone. Again, using these processes, these things, okay? So this is what you're learning. You're actually following in their footsteps, trying to do those things. I mean, this is a small lab. We don't have basically a lot of things. We don't have viruses to deal with. We don't have a lot of safety issues. If we're in the lab, we're going to deal with the safety, if in case something catches fire, because there is a potential for that. Then there are other things to deal with. But in this case, it's always an online lab, which is at least we get something better than nothing. Okay? This is basically it. This is what I was hoping to cover with you guys today. Do you guys have any questions for me related to this lab or to the class itself? Again, when you start working on this, you might discover questions, okay? Which is fine. Please ask those things in the appropriate discussion board so that we start working on it. It should take you working on it basically the class time, which is about 3 hours, okay? Plus about 4 additional hours, you should be able to get all of this is done, okay? In the discussion board, please, yes, not in the inbox. The inbox should be really reserved for something private that is really has nothing to do with the lab, or if you're running into some difficulties. Yeah, everyone's table will end up basically being different. That's a question that Jeffrey is asking. I don't understand, Jeffrey, what you're saying in there. The second sentence, I didn't understand it. The V versus T plot is the line that is actually going around up and down. I think it's a green line, okay? That is actually the data that is there. Those orange lines in there, that is actually the data in there. That's V's questions. Jeffrey, I still did not understand the initial graph that is shown. Yes, it's everyone's is different. Everyone's data is different because every time you run the simulation, the numbers that are generated are actually different from the next time actually you yourself come in and do the actual same lab. So once you do the data, stick with that data, okay? Live with that, okay? If you don't like it because it's too low or too high, then run the whole set again and don't include that set of data, the first ones. Okay, let's go back because Jose's got a question in here. Let's go back into the, let me run it from my computer, okay? Because I have the actual software installed. So let me try to run it from my computer to show you how this looks like from, and you can download this software. By the way, GeoGebra is free software, so you don't have to, and it's a good tool to have actually for your learning process. Actually, it's a good tool to have because you can do a lot of things with it. You know, it's not just for the this lab. You can actually do a lot of math with it. You can solve differential equations with it. You can do a lot of math with it. As a matter of fact, for me, I'm still basically using it for my classes as demos. Okay, so why is it? Okay, loading. Okay, for some reason it's taking some time in here. Okay, so this is the simulation. If you download it, again, this is on my computer right now. I was editing it earlier in the morning, and basically, so this is the plot. This is the data set in here, okay? This is, if I look at this point, is 0.4, this is 2, 3, 2, 4, 6, 8, and 10. So this point is between, it's around 4.6, 0.44, 0.46 on the time axis, and on the y-axis, it's less than 0.2. So think of this scale as 0.2. So this is 0.02. So you can divide the gradations. This is about 1.8. So it's a 1.8 versus 0.46. So that's the time, and this is the V1. I can take any point, like this one, for example, as being a V final. And this point is located between it's about 1.66 and 0.61 in terms of the velocity, okay? So this is V versus time. This is the velocity versus time. So that's it for my second table, not the first table. The first table is here, okay? And this is the average velocity, the average acceleration, I'm sorry, the second one. I probably, yeah, I have it labeled, the acceleration, and this is velocity, yes. Okay, now, the very important thing that you do is collect data, okay? When you do collect data, you have to click it probably twice or wait for it because it's taking time for my computer right now. It's running extremely slow, okay? So when you do that, you have a fresh of data to start with. So do not give me the first data. You have to do the second data. So at that point, I'm ready to fill my two tables. Both of them are ready. So I'm going to get the L, the D for my first table. I'm going to get the T1 for my first table. I'm going to get the T2 for my first table. I'm going to get the T3 for my first table. That's all my first table needs, really. Then I'm going to calculate the velocities and all of that. Then look at this graph in here. I can actually zoom in into this one, okay? And pick a point, okay? When I zoom in, I'm using just my mouse, the wheel on the mouse, okay, to zoom in. Then pick a point in here, 0.6. This is 6.2, this is 6.4. It's 0.63 actually, and this one is 0.1, 0.15. So it's 0. If I divide this division 1, 2, 3, 4, and 5. So this each one of them is 0.2. So this one will be 0.12, 0.14, 0.014. So basically divide it. So it's somewhere 0.125, just in the middle in here. Again, I'm just getting an estimate. I'm not getting accurate in here. So a number between 0.1 and 0.15 is 0.125, okay? If you want that. It's not 0.1, it's not 0.15. It's not 10, it's not 15. It's somewhere in midway, which is going to be about 0.125. This is V1. This is for my second table. Again, this is somewhere in between. So this is sitting right at 1.8 in here, okay? I can move this, by the way, okay? So there is no problem with me moving it. So this point is 1.8, and it's just below this mark, which is 0.35. Just 0.345, if you like, okay? Just in here, okay? And that's going to be my V2 for my second table, okay? And I have the times also, 1.8, and I have the first time 0.63, I believe that's what I took. So I can go back into my table and read those. For the first table, it's in here. The second table, the data is here, okay? This graph in here. This is the line that approximates this one, okay? Now I want to add mass. I'm going to add mass. Now I have added mass. So I need to collect data again, okay, when I add mass. So don't forget that, okay? I probably should write this one for you guys so that, okay? Once I click on data, I have a new set fresh of data now with mass. So I have a new T1 for the first table. I have a new T2 for the first table. I have a new T3 for the first table. And then I also can find for the second table, the T1, just dragging with the mouse, it's going to move. And this one and the other one, okay? Any point. It doesn't have to be this one, by the way. This one would work too as T final and V final, because all you're trying to find is just an average between the two. Now I have V final, which is this number, and T final, which is this time, 0.92, okay? And then I have T initial, which is 0.46 or 47, somewhere in between. And then between 0.15 and 0.2, right in the middle, is 0.175. Okay, that's my second set of data by examining this data set. That's it. That's my tables in there. Okay, I'm done with this experiment now. I can go get something else. Okay? Yes? It's a good idea to experiment with this. I know I am actually confident that you guys are the best when it comes to technology. Usually you're hands-on. So the minute you go in there, you're going to find some shortcuts to these things and you're going to get your data in no time. Especially the first one, it might take you a little bit longer time, but I'm sure as you get more familiar with it down the road, it's going to be easier. Now, if you're still having difficulty with it, please do not hesitate to ask, okay? Ask in the discussion in there. Yes? The blue line is just for the acceleration, the average acceleration. If we did the lab, we will get actually that data, okay? If we actually did the actual lab with the capstone device, you will also get the acceleration, okay? You will also get this one. So I'm trying to simulate as much as possible an actual lab. I have actually the probes in my home in here. I don't have capstone, I have the other one, vernier. Okay, and I think that's what your lab, what the college uses, vernier. So even if you have a vernier, it's the same thing. It's going to give you the acceleration, and it's going to give you also the velocity, okay? So that's basically the device. Again, I could have done this a lot easier. I could have given you the data and tell you to fill the tables, but that's not really getting closer to what the lab looked like. The actual lab has devices in it, and although you don't have them in right now, but this is as close as how they work in real life had you actually gone there and did these things. So I know, I'm aware of that, of this blue lines for the acceleration. That is actually 0.4 and this is 0.41. There is actually already a discrepancy between these two sets of data in here. Okay? Any more questions? What do you mean the brown? The brown is for the velocity versus time. There are two graphs in there. One of them is velocity and one of them is acceleration. You have to do the whole lab without mass, and you have to do the whole lab with mass. And each one, you will get two graphs. You will get one for velocity, which is the green line and the brown data, or you do the, and also the acceleration, which is the blue data and the black line. And also, if you do it with mass, you're going to get a brand new set of those two datas, okay? Again, the V1 and V2, you go to the velocity, which is those brown lines, and find one from the below, from the basically the earlier times, and try to find it somewhere on the x-axis. That's time, T1, and try to find its y-axis. That's V1. Okay. Do the same thing for a later time. Try to find another brown line, brown data basically, and see where it fits. Again, it's giving you a range for that. Try to find the time for it and the x component for it. Okay. You don't have to be accurate with this one as long as you are very close from it. Everybody else good? Okay, no problem. The others I did not hear from. Sarah, Alicia, Diana, Omar, Samantha, I think. Jose, Vanessa. Okay. We have two Amandas in this class. Kyle. Okay, if you guys don't have any questions today, I will be available, like I said, in the discussion. This recording most likely will not go online tonight, okay? It's going to be ready by tomorrow morning. Yes, it's going to be followed the next morning. because it's too late already and I'm an early sleeper. I actually go to sleep to bed early, so I'm sorry I cannot finish this. It takes a long time to download the video. So first of all, the video is not going to be available immediately on for me to download. So once it's ready, then it takes time for it to download and so on and so forth. Okay. Okay. If you guys don't have any questions, then for tonight, then I'll see you guys a week from today. But meanwhile, don't forget that I am just a click away from you guys. Okay. See you guys. Be safe, please, okay? And don't forget you have an assignment due this Tuesday. Bye.